So again, Kathy, I'm just showing you stuff that we can do that I would consider fair game. Challenging, but fair game. Projectile is launched from the ground, okay, from the ground, with an initial velocity of 88 meters per second at an angle of 70 degrees with the horizontal. What's the velocity, magnitude, and direction of the projectile after 4.6 seconds? Example 6, you found it okay from lesson 7? It's going to be there somewhere. Okay. Hey, I'm an adult. What's the angle in this question? Did I say angle? What's the angle in this question, Mason? 70. So that's fairly steep. 45 is about like that, so I'm going to make it steeper than that. Here's the ground, let's say, and there, 70 degrees. What's my initial velocity, Mason? 88. It's a projectile, so we're going to go T-table. X, Y. What two things can I write down without thinking about it? AX is 0. AY is negative 9.8. Am I ever going to use this 88? Not once I find the components. Did I say, Did I say angle components? So I'm going to break this up into Vx and Vy initial. Again, I typically do components as dotted lines, and because I have color ink, I'll almost always change the color as well. What I'm really saying then, Kathy, is those red lines wouldn't be part of the diagram that you would normally see. That's stuff that I've added. Vy, what? Was there a dumb way that we could remember that Vy was sine? You come up with something on your own. So Vy initial is going to be 88 sine 70. Is that a yucky decimal or a nice decimal? 82.69. You know what? 82.693 is probably pretty good because there's a 9 next to the 2. I'll go 82.693. And Vx is going to be 88 cos 70. Let me just remind you, Julianne, that this dumb shortcut, it doesn't work for the airplane in a crosswind or for the boat going across the river, because I won't always give you the angle with the horizontal in those particular situations. So you can't always assume, oh, Vy is going to be sine. Or, okay. Cos, of course it is. $30.098. That's a 5 sig figs and pretty good, I think. 30.098. Now, I almost haven't even read the question yet. I mean, I read the first line, but Erica, what do they want me to find? Read me part A out loud in a big, loud voice, please. Keep going. So here's what I'm imagining. Don't write this down. Here's the projectile. They want me to find the velocity after 4.6 seconds, which is going to be a slanty velocity. Could be there. Oh, could be there. You know what? I don't know if it's on the way up or on the way down. How could I figure that out? I hardly understand what you're saying. If what's positive? If what's positive? Which velocity? Because there's about 5 of them kicking around here, so I need to be really specific. Which Vy? Yes. Okay. Boy, it took a while, but yeah. A couple of ways. First of all, Kath, I could let Vy final be 0 and solve for t. That would tell me exactly when it was right there. And then if that was bigger than 4.6, I would know it was on its way up. If it was smaller than 4.6, I would know it was on its way. Sorry. If it was smaller than 4.6, I would know it was on its way up. If it was bigger than You know what I mean. Okay. But that means I'm going to find something in order to find something. You know what? I know I'm going to need to find Vy final no matter what. So what I'm going to do is I'm going to dulp here, but not yet. What I'm going to do first is I'm going to say, hey, what is Vy final? Erica, what was time? They gave me that, but I've scrolled down. 4.6 seconds, and I know A is negative 9.8, and I know that Vy initial is 82.693. Oh, probably my favorite equation because I've used it so much. Which one, Erica? Did you say D? I don't have a D. Yeah, and now you realize, oh, I was overcomplicating that. Which one? Vi plus AT. I'm going to be really lazy and go straight to numbers. In fact, what I might be tempted to do would be to have that sign value stored as my answer button so that I'm not even rounding up. Certainly you can use the 82.693, but I'm going to bring this on my calculator, Sam, because it's less typing, and I'm going to go answer button plus negative 9.8 times 4.6, stop. What if I'm really lazy and just want to do a ballpark estimate? What's a nice round number that negative 9.8 is really close to? 10. You know what? If I was really in a rush, I would say it's going to be roughly positive 82 minus 10 times 4.6. It's going to be roughly positive 82 minus 4.6. I'm going to try it on your calculator, but you got a positive Vy, yes? It's on the way up. So if I was in a real rush, I could actually just go times the time by 10, and if it's bigger than Vy initial, it's on the way down because whatever. So now I'm going to dulp. On the way up, you say, dunk. It's going up at an angle. Did I say angle? Components. Here's Vx. This is Vy final, which we just figured out. I forgot to write it down. That was dumb of me. 37.613. That's a nice place to round off. Is that what you all got as well? 37.6 round 3. If you used 613, if you used your answer button, that 3 might be a little bit different if you used the 82.693 and didn't use your answer button. Yes? People nodding? So 37.613. And Vx was 30.008. And now, Mason, we're back into familiar territory. There's the V that they want me to find. Where's the theta going to go? Bottom left or top right? Color, 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 color. You know that's starting to show up in my YouTube comments now. Thank you, whoever you are. Squared plus 30.098 squared. Square root. And I get 48.2 as a magnitude. Meters per second. At. It's going to be tangent. And again, I'm using tangent, but technically this 48.2 is the hypotenuse. I could use shift cos or shift sine if I really wanted to, assuming I've done the hypotenuse correctly. And in grade 12, I usually am willing to use an answer to find an answer too, so whatever. But I'm going to use tan theta equals opposite 37.613 over 30.098. You get 51 degrees? How would I describe the direction? Above the horizontal. Mr. Dueck, what would be an example of an A+ level question? I'll show you one in just a second. We'll be able to handle it, but it's just going to be it's going to have a lot of teeth to it. What's the velocity, magnitude, and direction after 12 seconds? You know what? I'll bet you after 12 seconds it's on the way down. I'm not going to do that question because I think you folks are getting the hang of this, which kind of brings us to the end of this, except could you get out your ultimate review, please? I'm going to pause the video for just a second. If you want to get out your ultimate review. And a good example of what I would consider a question with some serious teeth is going to be number 35. If you want to go to number 35. If you want to turn to number 35. This was from the June 2002 provincial exam. 02 is the year, 06 is the month. Number 35, Sam, you'll get there. Near the end. Liam, what are they asking me to find here?
Velocity, magnitude, direction.
We just did a velocity, magnitude, and direction question. Why is this one so much tougher, Mr. Dueck? They didn't give me time. I think I said to you we're going to spend most of our time finding time, but if they give me time, the question tends to fall apart. What did they give us? What's the only extra piece? They gave me the 25 meters per second, the 35-degree angle. What's the only other piece of information they gave me in the diagram? dx, the range. Any suggestions? And by the way, if you saw this, this is tougher than I'm going to ask. I might feel comfortable making this a nasty multiple choice question, but I would not make this, and in fact, now that I'm showing you this question, I probably won't make this a multiple choice question because I will always give you one multiple choice question that you haven't seen before, but I would not make this a written question. But I would be concerned if you left this blank. What's the first thing that I should do just because this is a projectile? Darn right. If I saw somebody and they hadn't done this, I'd be giving them a bit of a stink eye. I think we are, but what would I do next? And you're correct. I'm probably going to want to find time because once I find time, it's the one that can go in both columns. Now what else would I do? Well, I see an angle, so did I say angle? We would all reply components. So let's get Vx, which is, I think, going to be cosine. Which is 20.4788. That's a good place to round off. And Vy, which is sine. $25 sine 35, which is 14.3394. How many things do I have right now? 2 and 2. I need a third. Oh, what haven't I used yet? Dx. Do I need to make dx negative? Because when they gave me a dy from a cliff, Liam shook his head. No, I think to the right is positive, so we can let dx be 40. Which column can I find time with? Which equation can I use to find time? Oh, Nicole did the whole thing in her head. She said, Mr. Dueck, time is going to be dx over vx. It's going to be d equals vit plus a half at. A is 0. Dx equals vxt. Get the t by itself. On a test, I probably would have written out what I just said just to make sure I didn't make a silly mistake. But in my homework, yeah, I'd try and do this in my head if I could. So you're telling me it's going to be 40 divided by 20.4788. It's going to be really close to 2 because it's almost 40 divided by 20. You know what? I'm going to bring back that cosine value and just store it on my calculator so I can go 40 divided by, answer button. Like I said, it's going to be really close to 2. Because I'm using this value, I'm going to carry some extra sig figs. So 1.9534. $1.95324, Mr. Dueck. And did we have to pull out the quadratic formula to find time this time? Did we just use x equals negative b plus or minus the square root of b squared minus 4ac? No. No. And that's the nice thing. Horizontally, solving for time is always easier because a is 0. And so it cancels out the quadratic term. How's that going to help me? Well, what's this question asked me to find, Chris? No. You know what? I think it's asking me, assuming this picture is roughly to scale, I think it's asking me to find that velocity where we hit the wall moving down at an angle. Did I say angle? Did I say angle? And I'm not looking for you to nod your head. I'm looking for another word instead. So, that's what we're looking for. I'm going to dulp here. So I think the impact velocity looks like that. And I'm going to break it up into Vx, which I know, that's 20.4788. And Vy final, which is not 14.3394. The most common mistake when kids saw this question is they would say, I need a Vy. They would put this number right there. Don't write that down, what I just did. And you know what would happen when they did the trig? They would get 25 meters per second at an angle of 35 degrees below the horizontal because they had just recombined the two original components that they'd got from the 25 and the 35. And they never ever caught that because, oh, I didn't get 25, I got 24.9998, Mr. Dueck. Yeah, because you rounded off, but it's the same thing. And I got 34.96 degrees. So don't do that. That was a little silly mistake that always bugged me. Instead, we're going to find Vy final. But I know time. It's 1.95324. Erica, I have A, Vi, T. What equation can I use to find Vy final? There's a reason I'm coming back to you, Erica. What equation can I use to find Vy final? Our good old friend, yeah. And you know what? Because I can see I'm losing you and you're getting tired and you want to work on the take-home quiz. Let's go straight to our calculator. Let's go Vy final equals V initial 14.3394 plus negative 9.8 times answer button. Oh, this is good. It is on the way down, so it matches what the picture was showing. So that probably suggests that I'm doing this correct, although the picture might not be to scale, but let's pretend it is. So 4.8023, negative 4.8023. I'll put a positive 4.802323 on my diagram. The negative is contained in the downward pointing arrow. Where's the theta going to go? Top left or bottom right? Top left. Color, 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 color. How will I find the magnitude, Sam? Pythagoras. How will I find theta? Probably tangent, although sine and cosine, shift sine or shift cos will get you there too. So the extra step of having to find time and realize that you could, that's what would make this to me an A+ level question. But otherwise, Mason, I would argue, sorry, let's finish this first of all. I'll call it VIMP for impact. The magnitude is going to be this number squared plus 20.4788 squared. 442, I'll go to 3 sig figs. No, I forgot the square root. Sheesh! That seemed way too fast. How about 21.0 meters per second at, and I'm going to go shift tan without writing anything down because I'm running out of room because you folks are getting a little tired. (13.2 degrees). Below the horizontal. Can someone double check? This was question number 35. The answers are on the very last page of the review. Did I do it right? Is number 35 21.0 meters per second at 13 degrees below the horizontal, or did I make a typo? All right, we're right? Okay. Okay.